So let's take a look at DSVisualizer and linked lists. The mechanisms inside of here are emulating what happens in a linked list. It's not perfect, and there might be some tweaks that you have to do to understand this, but the idea is to be able to practice linked lists. So let's let's start simple. We're just going to add a couple items in the linked list just to see how this works. So I'm just hit add a couple times. You can see 4 times here, and then I hit start to start the sequence, and it's going to tell me, oh, so first one we're going to add an F. Now yours will be different. It randomly generates each time. I'm going to add the letter F. So I hit the add button, creates a new node out here. I put the letter F as the value for the node, and I'm going to check it out. And yeah, that's exactly what it wanted to do. So from the head, I created a node, and that's the start of my linked list. So next, I want to add a U. Same process applies. So, the head is fine. I'm adding it to the end of the linked list. So I start at the head, I go to the next node, and I keep going until there's no next, and then I add a new next. So I'm going to add in U right here. And that one's correct. So this process is very intuitive, but I don't want you to just simply make the list. That's good. It helps you understand what the list looks like logically and get a gut feel for it, but also practice the algorithms involved. Remember, I'm going to add the value H. Well, I'm looking at the whole linked list. I don't know where the end of the linked list is at this point. I only know where the head is. And so when I start with the head, I say, well, is the head null? Nope. Well, let's go to the next one. So I have a next one. So, so I'm going to check, is its next null? Nope. Go to the next one. I check if it's next null. Yeah, actually it is. So let's add a new one, H. And then finally, M. Start at the head, F, nope, not next, nope, not next, nope, not next. Up, there you go. Add in M. And so adding to a linked list, relatively straightforward, especially intuitively. I find the end of it, I tack it on, but how do I find at the end of it? It's going to be your trick and code. How do I iterate through that list to get to the last one involved? So let's take a look at set real quick. Oops, sorry, let me just do this. We'll add 3 of them in and then do a couple sets just to get it going. And then we'll let us practice that algorithm again, and we'll be able to talk about it, how this navigating through the tree falls into other, I'm sorry, I said tree, list. Navigating through the list falls into the other one, the other algorithms as well. So add J. So we start at the head, which was null, and then we add J. By the way, let me hit the delete button real quick. When I add one, I can delete it real quick, just in case you accidentally hit it again, but to be able to show it again. So when I say add J to the list, well, from an algorithm standpoint, is the head null? Well, yes, the head's null, so I'm going to change the head to be J right there. And that's what happens. So now I say Z. Well, is the head null? Nope. Well, then let's go to the next node. So head.next in this case. And so the next node is J. Well, is the J's next null? Yeah, well, yeah, it is. So let's add it in here. So Z. All right. So again, A. So is the head null? Nope. J, no. So I say that, it makes perfect sense, but how would you translate that into code? Well, what we want to do is we want to start with the head. If the head's null, then we know that our list is empty, and we need to do something with the head when we're adding it in. Otherwise, how do we keep going through the list? Well, remember, we're going to look at this iteratively. So all we need to do is loop through the list, where what we're going to change is which node we're pointing to. So if head's not null, well, then head, whatever's pointing to head, is the next node we're investigating, is the next node we're going to iterate through. So we can create another variable, if you will, and just let's just put it over here. Next variable, next node is pointing to J. Well, if J's next is null, then we added it in. That's what we did last time. If J's next is not null, well, the next node we're going to investigate, the little variable up here, is equal to the node we are investigating ourselves, dot next. So we're going to point this little variable, instead of J, we're going to point to Z. And then when we get to Z, and we say, is this one null? So yeah, it is. So we're adding A. All right. And then we're going to set the value U. So at 1 to be equal to U. So this is interesting because the same logic applies. So the index is equal to 1. Well, up front, we can check if the head's null and if it is, then we don't set anything. Um, but we can also say, well, let's check the index. If the index is less than 0 or greater than the size, then ignore it. It's useless. So if I want to check the indices, it allows me to actually use a for loop to work through this. So if I use a for loop, I can say for index number of times, 0, 1, or 2, loop through and update the node I'm going to mess with to be the next node, starting with the head. Or I could do it with a while loop that's saying while the current is, if the head's not null, the current is the head, while the current dot next is not equal to null, loop through it, and then keep the counter that way. Now, we'll talk about this in other examples, other place, but the for loop works really, really well here, as long as I check the boundaries, because I have to count anyway. I'm going to be counting through. So the index 1 is going to be used. So which one of these is index 1? Is it J? Is it Z? Is it A? Well, remember, everything in Java and a lot of computer science is 0 based. So the first item is 0, the second item is 1. So it's actually, if I hit the edit button here, it's Z that I want to change to be U. And I'll check that out. Yep, that's the right one. So I'm going to save it and hit next. All right, set the index at 1 now to be Q. Well, it happened to give me the same index. It could have hit any of those 3 with the random number generator. It happened to give me the same one. So I can change that one to Q again, and we go from there. Now, let me do that one more time here. I'm going to do a bunch of sets just to make sure we have a different one. Again, that's intuitively, you can count and know what to do, but let's do it algorithmically. Again, repetition is good. It's going through this multiple times is good. That's what this tool is all about, doing this a whole bunch of times. So K. K. Oops, I'm sorry. Yeah, so I delete that one. Oh, crud, I hit K twice. I forgot to validate. What do I do? I was too exuberant right here. Well, what I can do is say change next, clear next, and then that clears out that one that I accidentally built. So I hit next. There you go. So that's much better. Now add S. So I should probably work through the algorithm, but I'm going to do it with the set in a second. I'm going to add M inside of here. So I added my 3 values. So now set value at index 0. Let's do this through the algorithm now. So 0 is greater than or equal to 0. It's not negative, and it's less than the size. The size being 0, 1, 2, 1, 2, 3. So 3 items less than the size. So set the item at 0 to be Z. So I say, well, my starting node is equal to head. And for int I is equal to 0, I is less than index, I plus plus, something like that is probably the algorithm I would do. Then I'm going to start with K here. I'm going to start the node that is K here. And I'm going to loop 0 times. I'm going to move it forward 0 times. So, well, okay, it's this one right here. I'm going to be changing to be Z. All right, so validate. Yep, that's right. Let's save it and move on to the next one. Okay, well, it did 0 again, so I'm not going to belabor that one. Hopefully I get a different one. I did a bunch of them here. Random numbers generator stuck on 0. Let's see if we get another one here. That's the problem with random number generators. Shoot, they were all 0. So let's. Oops, I don't want to do that many. Let's do 3 again, and then we'll just do. Oops, shoot. 3 again, and we'll do just a whole bunch of sets, and hopefully get one that's not 0 here. All right, so just quickly add W, add T, add E, 0. Hopefully, well, we know I did one. We got it there before. Doesn't need to change anything there. There you go. So now we got 1 to be I. Okay, so the current node, so index I is not negative, it's less than the size. So if we look at the starting node, the current node is going to be equal to head, it's going to be M. For I is equal to 0, I is less than, in this case, 1, index. Then let's change it. So current node is equal to M. Okay, well, that's 0. And then add 1 to the index, and then say current is equal to current dot next. Okay, so that's T. Okay, so then we try and loop again. Well, now we're at 1, and so we don't loop anymore. We're stuck here. And so we just say current dot set value is equal to the new value, I. All right, so let's do that one more time. Okay, so 0. So current node is equal to head. Loop. Okay, well, I don't loop any times because the index is 0, and so I never loop. So I'm going to edit that one to be k. And then I hit next. All right, well, let's see if I can get a 2 here, at least a 1. Why? I'm not having, oops, I'm not having any luck here on that one, but it happens. J. Okay, so now we have 1 to be equal to L, so let's try that again. So current node is equal to head, because we know this is between 0 and 2. So current node is equal to head. All right, loop through it. So head current is equal to current dot next. We're now equal to 1 in the loop, so we change this one to be L. 0 to be X. That's not interesting. See if we get one more here. 0 to be W. And we had a whole lot of zeros here. We'll do it one more time. All right, so current is equal to head. Loop through it. Current is equal to current dot next. Loop it one time. Okay, it must be this one. We changed it to W. And let's just pretend this was 3 for the second. I know it's not going to work that way. But current is equal to head. Current is equal to current dot next. I plus 1. Current is equal to current dot next. I plus 1. Then it would be this one and it would set it. So as long as we check before we do the loop that the index is between the 0 and less than size, size minus 1, then this will work just fine. All right, so that's the idea behind the set and the get, and navigating through this becomes a important algorithm for doing all of these. So and basically other things as well in the linked list. So we'll leave it there. Come back here and show you remove and insert here in a second. But this is the linked list within DSVisualizer to get started with. So play with this a bunch and make sure you're getting at this, and make sure you're paying attention to the algorithm like we did here too. Just doing add and set, I could have done this in a 2-minute video, but I spent the extra 10 minutes here so that way so I can show you the importance of repeating it and practicing it and getting it the algorithm into your head as well, especially as you start looking at code.